Hello everyone, I am Trisha Dash, lecturer at the Department of CSE Brack University. So today we are going to learn about binary search, and this is the second lecture on searching. So we have already learned about linear search. So in linear search we start from the leftmost element, and uh, by one we will check with the element that we are searching for, and if those are equal then we stop our searching, otherwise we will search from the left towards the right. So this was linear search, and the next topic is binary search. So in binary search we have to remember one thing, that the list or the array should be sorted, otherwise this approach will not work. And in this approach we will repeatedly divide the searching interval into half and check only the middle element. So this is the left index of our search interval, and this is the right index of our search interval. So right index is 9 and left index is 0. So we will find out the middle element. So this is the middle element, and the middle element's index is 4. And we will search, we will just check that if 15 is equals to 23, as it is not. So as we know that the list is already sorted, so as 23 is greater than 15, we do not need this portion, the left portion of this array or this list. So we will only need the list from the immediate right element of 15 and to the rightmost element. So we will get the next, we will need to search only in this area. So now this is L equals to 5 and R equals to 9, so the middle element is 56. Now we will check if we are searching for 23, so we will check that if 56 equals to 23, as it is not, so we know that 23 is less than 56, so we do not need this portion of the array to be checked again. So we only need these two elements now. So here then we will again do the same thing on this. So L will be 5 and R will be 6, so our mid element will be 5. So we have got what we wanted. So when we check this mid element with which we are trying to find out, so 23 is equal to 23, and so we have got it. So I think we understand the simulation, so let's move towards the code. Now this is the code for binary search. So I have written a function. So this is the function which is named as binary search, and this is, I am sending a sorted sequence here, or this will be the list. So we are sending the sorted list and the element which we are trying to find out. Okay, so then L equals to 0 at the first, we have seen this in the simulation, and R equals to the last element's index. So this is length of the sorted sequence minus 1, or we can say this simply as n minus 1. Okay, so while L is less than or equal R, then we have to find out the mid element. So so the mid element, I mean the mid index of the mid element. So this, now we are finding out the mid element with this formula. So L plus R minus L divided by 2. You can also write this simply like this: L plus R divided by 2. These both are the same. So then if the element in the mid index is equal to x, or which we are trying to find out, this is x, so is equal to x, then we will return the mid index. So we will return the index that we have found x in this index. Okay, and if the mid index is not the element in the mid index is not equals to x, then we have to find out if x is greater than the mid index element, or it less than. So if x is greater than, sorry, if the mid index element is greater than x, then we know that, okay, so x is smaller than, really x is smaller than mid element. So we have to find search the left portion of the mid element. So search the left portion. So in this case we will have to shift the R. So we shifted the R. So we had a example here. So here before R was 9, and when we find that 23 is not equals to 56 and 23 is less than 56, we shifted R from 9 to 6. So we are doing the same thing here, that we are shifting, x is smaller than mid element, so we will need only the left portion. So we shift R to the mid index minus 1th position, or otherwise we will shift L to mid index plus 1 from plus 1 position. So here in the first case we have done that. So as 23 is not equals to 15, so we need, and 23 is greater than 15, so we need to check the right portion. So we shifted L to 5. So here L, we shifted L to 5. So if 5, this is 5 because the mid was 4, the mid element was 4, so we shifted L to mid element plus 1. So we are here in L equals to 5. So that's why we take L to mid index plus 1 position. So, and if we never get the elements, then we will return none. So none is a specific kind of data type. You can just search and find that we use it when we need null type of data, that nothing. So this will return a none type of object which we can consider as null or nothing. So outside of the function, here we call the function. So I called it binary search, and here I gave in a list, and I'm trying to find out 2. So let's try to find out 6. So if index equals to none, if this is the case, then we did not find the element we are searching for. Otherwise we have found it and find it, and so here we will print the location. So let's run the code. Here we say that 6 is found at the location 3. So 0 1 2 3, yes, this is correct. So if we try to check uh, with an element that is not in the list, so let's try. So this is not found.